So the 802.11 standard now, defined by IEEE, right, gives us these specifications for wireless connectivity. One important distinction is that wireless LANs don't have an address associated with the physical location as wired LANs do, right? So 802.11 is an addressable unit called a station, or an STA. It's called a station. A station is defined as a message destination that might not be a fixed location. Another distinction is made here between mobile stations and portable stations. So a mobile station is one that accesses the LAN while moving, and a portable station is one that can move from location to location but is used only while in a fixed location. Just kind of some interesting things about them. Now, the basic architecture of 802.11 uses a basic service set, BSCS. So a basic service set is a collection of devices, right? Like stations that we just talked about, that make up the wireless LAN. So the basic service area is this coverage area that these access points are going to provide us. The infrastructure mode always has one or more access point with it. And yet an independent wireless LAN without an access point is called an ad hoc network, right? To connect to the basic server set, 802.11. And so that's going to require some sort of distribution system. It makes sense, right? A DS as an intermediate layer. So data moves between the systems then through the DS, through the AP, right? So basic server set, BSS, a basic service area, which is the coverage area of an access point, and the ad hoc network, which is this independent wireless LAN without an access point. Just some definitions now to know. So as long as the station is within a BSA, it can communicate with other stations in the BSS, right? And I'm going to show you a picture of it in a minute. So to connect two BSSs, 802.11 standard requires this distribution system, as we said, as that intermediate layer. We'll take a quick look at it here. So IEEE 802.11 standard, the 0.11 defining the wireless portion, uses, as we said, remember 2.4 to here 2.48 gigahertz roughly. And so each frequency band that you're using is going to have various channels within. Each frequency band contains channels. A channel has a range of frequencies, right? So 802.11 defines 11 different channels. Sometimes these channels will overlap and interference can occur. So as a security tester, if someone is complaining of interference, I've even had interference with remotes. And the first thing I look at are the frequency that the remotes, the channels, frequency and channels that they're operating on. Now, the basic architecture of 802.11, in the United States, again, I said the range was 2.4 to 2.48 roughly gigahertz. So think of frequency as a superhighway, right? And each frequency band contains channels. So each superhighway contains channels. And so sound travels through the air just as waves are going to travel through the ocean, right? Like ocean waves. Well, these sound waves, the length is measured from the peak of one wave to the next period in the sound waves. And sound waves can be amplified, right? And so we have this amplitude, which is the sound wave height. We have this frequency, which is the rate at which it repeats. this cycle, which is the completion of repeating patterns. Hertz, we talk in terms of hertz, which are the cycles per second, right? More hertz, the better. And bands, which have these different frequencies. So just kind of interesting. I posted the chart here on wireless information, which shows you the range and the wavelength if you're interested. So continuing with this wireless technology overview, right? We have infrared technology, which cannot be seen by the human eye. It's restricted, frankly, in its capacity by a single room or line of sight. It's always considered line of sight. It cannot penetrate walls, ceilings, or floors. Often your remote controls today will use infrared signals when pointing to your television, a wireless technology. There's also narrowband, which is going to use microwave radio band frequencies to transmit data. Cordless cell phones, if anybody still uses them, and garage door openers for sure, they use the narrowband frequency. All of this can, of course, cause interference. Now, there's a little bit here and in the literature that we read this week on the spread spectrum, including modulation, which defines how data is placed on a carrier signal. Data is spread, of course, across a range of frequencies. Really what I want you to know is that there are frequencies and channels within them, and those are usually the reasons for interference issues, right? I think that would be the point. Now, I mentioned the IEEE 802.11 project. So they had a standard A, and then the next one, which is when we put a letter on it, it's the approved project. And then B was next, right? And this started in October of 1999. It's just called the 802.1B standard in the 2.4 gigahertz band. And it used for security of this wireless communication, WEP. It's called Wired Equivalency Privacy, or WEP. And it gave us a sense of security at first, but it really was a false sense of security. That the data being transferred on this wireless LAN was being protected. WEP. It was not. It was easily hackable. It was a good try, though. It's a good first start. So as I mentioned, you had the A standard, the B standard, and then even the G standard, still operating in the 2.4 gigahertz range. Notice A went to the 5 gigahertz range, but G was back to the 2.4 gigahertz range using OFDM modulation, and basically back to the 2.4 gigahertz range, it was able to increase throughput. Throughput is really the goal, right? Don't we all hate a slow wireless network? Additional IEE projects include 802.11i, which improved security protection of the wireless signal from WEP, which we just talked about. It's a good first try, to WPA, right? Wi-Fi protected access. And after some time, it also was discovered to have security vulnerabilities. And so we continued to develop the process. 802.11e was another approved project. It addressed the problem of interference. So when interference is detected, signals can actually jump to another frequency more quickly. The 802.11 standard operates in the same frequency as the 802.11g, but it has multiple antennas now and wider channels, which will increase the speed and capacity of the information being transferred. 802.11 AC, we're back to the 5 gigahertz band, and this is all about throughput, right? Up to 1 gig per second. Can you imagine that? Shoo! That's pretty good for wireless, huh? And 802.11 AD, dubbed Y-gig, right? Transfer rates up to 7 gigs per second, but we're going to see how that worked out here in a second. Now, Wireless standards. I took this and I made kind of a summary from some other slides that I have. So here are the 5 basic standards and just a little ditty about each. B was really the first Wi-Fi standard, right? G increased the transfer rates, which was important. N included backwards compatibility to A, and then 802.11 AC again just increase the transfer rates. And you can see them summarized in the slide at the very bottom. For each, you see the frequency, transfer rate, range, and capability. You see the range up to 300 feet now. Transfer rates reliably up to 1 gig using a frequency of 5 gigahertz. Anyhow, and the compatibility, the backwards compatibility, which is key, right? So there are additional IEEE 802 standards. One person's workspace is called a wireless personal area network, or WPAN, right? And in a WPAN, the maximum distance between the devices is usually about 10 meters. So with Bluetooth, for example, the communication specification, which is a fundamental part, that is your own wireless personal area network. When you turn Bluetooth on your phone and share a link with a neighbor sitting next to you at the airport, you've created your own wireless personal area network using Bluetooth. And so you can connect portable devices such as cell phones and computers. I often use it to get good wireless signal in the airport, my own trusted secure signal, right? So the Bluetooth version uses this 2.4 gigahertz now. It didn't always. The most recent version of Bluetooth is on the 802.11 band. Now, 802.16 covered wireless metropolitan area networks, or WMANs. And the most widely used implementation of a wireless MAN technology is called WiMAX, or the Worldwide Interoperability for Microwave Access. So WiMAX, frankly, was a failed venture. Another MAN standard, right, the Metropolitan Area Network, with a goal similar to mobile WiMAXs, is called the Mobile Broadband Wireless Access, MBWA, right? If you want to know more, you can visit IEEE website, and research new and exciting projects that are being added to in IEEE, okay? So I just talked about the 808.20.2, the MBWA standard. There we go. This is a slide that shows additional standards. This is kind of a summary of their standards that they're working on. As I mentioned, WiMAX is a failed standard, so I wouldn't worry about that one too much. Understanding authentication. So it's just as important, or more important, authentication, and then identification, authentication, authorization, and then auditing. Those are really the keys to CIA. So we want to understand authentication. The problem of unauthorized users accessing resources on a network. This is a major concern for you and me, for us as security professionals. A wireless increases the potential for security problems. In fact, in your SASE exercise of week 5, I personally am most concerned about authentication that gives you access to the SASE cloud, because now everything, all of your security apps are consolidated in the cloud, and it is reaching back to the network data centers for you, right? But if you can get access to the cloud, so authentication is a key part of that, right? So as I said, this is a problem for security professionals, right? And we're going to discuss that in the following sections. We'll take a quick break and come back for part 3.